All right, so this is question number 10, January 2019. All right, the A part says that P is the matrix minus 1, 2, 0, 5, Q is the matrix AB, and R is the matrix 11, 15. It says, using our calculation to support your answer, explain why the matrix P is a singular or a non-singular matrix. All right, now to determine if a matrix is singular or non-singular, what you have to do is you have to find the determinant. If the determinant comes out to be 0, the matrix is singular. If the determinant is not 0, the matrix is non-singular. So P is the matrix minus 1, 2, 0, 5. So now let's find the determinant of P. The determinant of P would be equal to, so what you're going to do is that you're going to multiply the leading diagonal elements. That is minus 1 and 5. So it's minus 1 times 5 minus 2 times 0. Now minus 1 times 5 is minus 5 and 2 times 0 is 0. So the answer is minus 5. Now, since the determinant of P is not equal to 0, P is a non-singular matrix. It's that simple. It says, using a calculation to support your answer, explain why matrix P is a singular or non-singular matrix. The way it works is this. If a matrix is singular, its determinant is equal to 0. If the determinant is not 0, the matrix is unsingular. In this question, the determinant of P is minus 5. Therefore, P is a non-singular matrix. All right, so if I did that, you're good for 2 marks. Next, we're told that given that PQ is equal to R, determine the values of A and B. So PQ is equal to R. This is P. P is minus 1, 2, 0, 5. That's P multiplied by Q, which is what? A. B is equal to R, which is 11, 15. Stay with me. Now, two matrices are equal if they're of the same order and corresponding matrix are equal. And if two matrices are equal, they're of the same order and corresponding elements are equal. I can't really do anything here unless I first do the multiplication on the left. I cannot determine the value of A and B unless I first do the multiplication on the left. So we're going to multiply our two matrices. We're going to multiply the rows of the first matrix by the column in the second matrix. If I multiply a 2 by 2 matrix by a 2 by 1 matrix, I'm going to end up with another 2 by 1 matrix. So let's multiply the top row by the column AB. First element in the row, minus 1, times the first element in the column A. So minus 1 times A is minus A. Then second element in the row, 2, times the second element in the column B. So 2 times B is 2B. If I multiply the top row by the column, I'm going to get the top value in the answer. All right, so I feel I'm going to need a little bit more space here. All right, let's see what we can do. because I think this is going to turn out to be simultaneous equation. All right, or I could be wrong. Let's multiply the bottom row by the same column. 0 times A, first element in the row is 0, times the first element in the column, which is A. 0 times A is 0. And then 5 times B is 5B. All right, so it's not going to be, and this is equal to 11, 15. So now what I can do is that I can compare elements. I have one matrix equal to one matrix. In that case, I can compare elements. Because when two matrices are equal, they are of the same order and corresponding elements are equal. It means, therefore, that the bottom element on the left, which is 5B, is equal to the bottom element on the right, which is 15. Divide both sides by 5, and I'm going to get B is equal to 3. Now, the top element on the right, on the left, which is minus A plus 2B, is equal to the top element on the right, which is 11. But we already found that B is equal to 3. So this is A minus A plus 2 times 3 is equal to 11. Minus A plus 6 is equal to 11. 6 minus 11 is equal to A, and so A is equal to minus 5. So A is minus 5 and B is 3. Next, this says, state the reason why the matrix product QP is not possible. All right, QP would look something like this. Q, which is A, B, multiplied by P, which is minus 1, 2, 0, 5. So in other words, I'm multiplying a 2 by 1 matrix. I'm multiplying a 2 by 1 matrix, and this is the order of the matrix, by a 2 by 2 matrix. All right, now, so the 2 by 1 and the 2 by 2, they are the order of the matrix. And when you have the order of the matrix, the first number is the represent row, and the second number represent column. Row, column. Now, two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. So now, the number of columns in the first matrix is 1, is not equal to the number of rows in the second matrix, which is what? 2. So the matrix product QP is not possible because the number of columns in Q is not equal to the number of rows in P. Ladies and gentlemen, two matrices are compatible for multiplication when the number of columns in the first matrix is equal to the number of rows in the second matrix. If the number of columns in the first matrix is not equal to the number of rows in the second matrix, you cannot multiply the two matrices together. The two matrices will not be compatible for multiplication. All right. All right, let's do the vector part of the question. I was planning to do them separately, but let's just finish it. B. So B is the vector part of the question. It says OABC is a parallelogram, and this says X is the midpoint of so it's OABC. So let us say B is going to go here, and C is going to go here. X is the midpoint of AB, so in the middle of AB is X. It's in the dead middle, and Y is the midpoint of BC. So in the middle here is Y. Now, OA is R. So the vector OA is R, and the vector OC is S. The vector OC is S. So remember, a matrix might be represented as a column, what? Vector. A matrix may also be represented by common letters. So here, the matrix OA is R, and the matrix OC is S. This says, given that OI says, complete the diagram below to represent all the information given above. I think we did that. I think we did that. We want to print it up. This is R. This is S. All right. So we did that. So that is good for 3 marks. We put in all these values, and that is good for 3 marks. It says, given that OX plus OX plus OY is equal to R, is equal to K into R plus S, where K is a constant. Using a vector method, determine the value of K. All right, let's figure that out. All right, it says OX plus OY. So the first thing I would do is, let us determine OX. Now, most times in matrices, when you're asked to find something, most time in matrices, when you're finding something, you're going to use the triangular law of vectors. Sorry. Most times in vectors, when you're finding a vector, you're going to use the triangular law of vectors. So I'm going to say the vector OX would be equal to the vector OA plus AX. This is the triangle law of vectors. You're going to start at O, end at X, and the next letter goes in the middle. So it's like you're following a path. OX is equal to what? OA plus what? AX. Now, OA we already know is what? R. Now, we know that this is something that is known, that the vector AB is equal to the vector OC. They're equal, which is equal to what? R, which is equal to S. Now, the vector OC, which is at the bottom, is equal to the vector OB, which is at the top. Now, AX is equal to a half plus a half of what? AB. So this is equal to R plus 1/2 of S. All right, that is what OX is equal to. Now let's get OY. Now OY what gonna help us? OX plus OY. Well, yeah, man, let's continue. OY would be equal to OC plus CY. Now, here's also something that we know. OA is equal to CB, which is equal to R. So this is going to be OC, which is S, plus CY, which is a half of CB. So this would be equal to S plus 1/2 of R. Now, therefore, OX plus OY would be equal to R plus a half S plus S plus 1/2 R. So a half S plus S is 1.5 S. Do you agree? A half S plus S is 1.5 S. Or if you want, you could simply do this. LCM, which is 2. Put this over 1, put this over 1. 1 into 2 is 2, 2 times R is 2R. 2 into 2 is 1, 1 times S is S. 1 into 2 is 2, 2 times S is 2S. 2 into 2 is 1, 1 times R is R. So what you would end up with is, at the top, you're going to have 3R plus 3S, and this is over 2. If you factor out the 3, you're going to end up with 3R plus S, and this is over 2. Now, this is the same as saying 3 over 2 R plus S, which is equal to K R plus S. So therefore, K would be equal to 3 over 2. K would be equal to 3 over 2.